Welcome again to the next tutorial. This time we want to talk about XML and HTML, and we will solve some questions or solutions for questions, so that we deal a little bit with these special format languages. So let's directly start. The first question in our tutorial sheet is the following. Remember the table structure for students, courses, and the relation student in course. And they should give now a possible representation in XML so that these database tables are represented in a file which is formatted with XML. You don't have to write the DTD or XML schema representation. It's just the XML, the pure XML. I will show you also a simple trick where you can test if your XML is at least well defined. Okay, so let's directly go into a simple version of XML creation. If you use any editor you want and you store it with a .xml, then you have XML representation, and then you can directly start with the representation. So in the lower part you see again these relational database tables, and now you have to represent this stuff in XML. So you need, first of all, you need a root element, and let's say the root element is named university semester. University semester. So if we have a root element, we need a start and an end tag. The end tag is the same, just with a slash, university semester. And then you can start with the different settings or the different tables. The different tables are these three tables: university courses, students, and student in course. So let's start with the university course. We again need a start and end tag to represent this table. You can say table or something like that. I just name it with a name like here. So I give university course, and we need an end tag as well, university course. So this is the complete table, and now you have to create the different contents. So there are different possibilities to represent this. I choose the following because it's very difficult to connect information. Therefore, each record should contain the whole information, even if you have a version of redundancy. You will directly see what I mean. So let's say each of these lines here, so each of the records is now a new block called course record. With a start and with an end tag. And each contains now these different columns or attributes. So the first one is the ID. And here we can define additional constraints. You have another possibility to directly put the information as attributes into the different tags, but I always follow the style that the attributes really contain additional meta information, and then you have to select how often you want to repeat the meta information. So for example, you can make one additional line where you say what is the primary key or something like that. So it's up to you how you design it. For example, you can say primary key definition, and then you add key, for example, or tag, so that you identify this. I select this style here, which contains a little bit of redundancy. In this case, I define that ID is the primary key. And everything here is up to you. You can define all of the names. You can define the whole structure. So XML is very flexible and is very independent from other formats. So you can define anything what you want. So I define ID, key, primary key, and then so I say that this is a primary key. It's a constraint. I can add also other constraints, and then I can have the content of this record column or element. The next one is the title. We just fill in these two columns here. You can of course continue with additional columns. So let's say title, and the title is Information Technology 1. Another possibility is that you use here just single text, for example, primary key, yes or no, or on, off, or things like that. But anyhow, you need additional logic behind, or you have to define a very intelligent XML schema definition to really get a complete valid syntax check. So we just want to get a very elementary setup. So therefore, we now repeat this. So it's a list of elements. The next one is the course 1223, and this 1223 is orbit mechanics. And the next one is the 12112, and this one is mathematics 1. And then we have one additional. And you see you have a lot of redundancy or a lot of additional overhead to the pure information. Of course, you can limit this to very short markups, but then it's not so understandable anymore. So there's a difference between human readability and machine readability. Spacecraft engineering. So now we have this complete table where we have a sequence of records, and each record consists of an ID and a title in our case. The ID is a primary key, therefore we have to check that these numbers are unique. You can do this, or you can add additional checks, for example, with XML schema, things like that, but here we don't take care on that. So then we have to go to the next table. So let's go to the table students. The table students is named students and has an end tag. And then we have again the records. So the same like here, we call it student record and student record final tag. And then we have the different content. We have an ID, a name, and a first name. So again, we have the ID, which is a primary key. So let's use the same. The first ID is 114423. The next ID, the next part is the name. In this case, Smith. And as I said, it's maybe not the best structure for this, but you should learn a little bit to play with this XML style. So create your own names, create the structure, because it's really easy in the use. The difficulty is if you want to make it really valid, and that this validation can be checked automatically by the different software modules. First name is Betty, and end tag first name. So that we have these records now, and we can now create the different records. So let's integrate 4 of the records. 114424, Miller, Frank. Here we have the 104428. It's this table here. Ward, Jonathan. And then we have the 95511. Right, Jane. So what you see compared to a database, the single elements here have no relations to each other. It's just a definition. The relation can be in some cases made with an XML schema definition, but in a pure XML, it's completely a separate information. It's just a format. The database really checks if a primary key is a primary key and if it is unique and things like that. Okay? So finally, now we have the university course and the students. Now we have to make this connection. So we have to create a new table or a new format for the table, which is called students in course. Start and end tag. Students in course. And here we have again the records. So let's call it a registration record, because this shows us the registrations of the students for the individual course. Registration record. And the end tag, registration record. So, and here we have again the entries. So let's have a look. We have an ID, which is a primary key, and then we have two columns with foreign keys. So I use ID, which is then again a primary key. So let's just copy and paste it from here. Let's define it as 1. And then we have an additional column called course ID, where the key is a foreign key. So what you can do here now is, for example, that you define foreign key and primary key with the tags yes and no, things like that. So it's completely up to you how you create your format. Some formats are better, some formats are not so manageable in automatons. So it's completely up to you. In any case, you need a description what the content should be and how it can be used. And finally, of course, you need some additional program. Therefore, XML just offers libraries and things like that in programming languages, because you have to use this format just as a read-in mechanism or as a storage mechanism, and you need a read-in mechanism, and then you can use the data. And then we have an additional column which is called student ID, and this is also a foreign key, and the student ID is 114423, so that now the student is registered for this course. And we repeat this information 3 times, because we have here 2 and 3, and this course 23 where the same student is registered, and 23 where another student is registered. So that's it. You save it, and then you have a nice structure. With a normal editor, you have no chance, you have no highlighting, you don't see this style of XML if it is well defined, or if it is also valid. So therefore, an XML editor is much more of much more benefit. But there's a simple trick. If you open this with a browser, all browsers nowadays are able to understand XML. You can check this. So for example, if you open this with a browser, oh, you see, there is an error. So this is the nice thing if you have an XML editor, or if you open it with a browser, because if you have typos like here in the line 26, so let's open line 26 again. In line 26, we used a wrong end tag. So student record and student records. So let's change this. Of course, we have to change it now at each end tag. And if we store it again, and if we open it again, then you see now no errors are anymore, and you have this highlighting. You can have this tree-based view. So you have the primary root markup, then you have 3 sub markups, And then you have lists here where you can also have the different views. So this structure is also available in XML editors. The highlighting is also available in XML editors. But you just need nothing more than a normal editor, any editor you want, and you store it with the extension .xml, and then you have everything what you need. So therefore, that's it. Let's continue with the next question. So then the next question deals a little bit with HTML. So we want to create an own web page, and this web page should contain information about our person. So let's read the specific question. Create an HTML web page about your personal or about your person, including images. So again, we just open an editor, and for example, I create now a file, personal webpage.html. And again, it's quite simple in this case that the structure is very similar to this XML structure. The only difficulty is that as a beginner you have to know all of these individual tags, because now the difference is that in XML you define your own names of the markups, and in the HTML you have predefined because they define the style and the view of the different inputs. So each HTML file starts with HTML. It's not case sensitive, so therefore you don't have to take care on that. But I usually write the markups in uppercase, and then it contains two parts, a head part, and you see again it's with start and end tags, but in HTML it's not so consistent, because there are some tags which don't need an end tag. You will see later. In the XML version of HTML, you have always a start and an end tag, or you have this backslash at the end, like in XML defined. Watch the lesson. And then you have the body part. The body part contains the real information, and the head contains additional meta information. So for example, in the head you can define a title which is shown in the web browser. So let's define the title: Alexander's web page. And again, the same style like in XML, you have a start tag and an end tag. So before we started the first time in our web browser, let's have an additional information. For example, a headline. So let's say H1 is the first headline, and this H1 is defined. You have H1 to H6 with different sizes, for example. And even if you don't define any additional styles, you have the standard style, and you have already usable and I won't say nice, but or attractive, but a usable version of document. So this is Alexander's web page, H1. Let's store it, and let's have a look in the browser. So if we open it with a browser, you will now see the following. This is Alexander's web page, and here you have this title, Alexander's web page. So first step is done. Now we can extend this information with additional things. So let's start here with the following information. Maybe I increase the size because we don't need these tables anymore. So let's continue with the following stuff. First of all, a short block with additional greeting and information. So hi, my name is Alexander, and I'm a teacher at the Technical University Munich. So this is a nice additional information. So let's have a look. If we open it and if we reload the page, it looks like this now. And then maybe as we have this Technical University of Munich here, this name, we can directly set maybe a link to this web page of the Technical University. So let's make this. A link is set with A, and then we have to define an attribute href equal, and inside of this we set the URL, the web page link of the Technical University, which is this one. And then we close this tag. We write what should be visible as the output of the link, or as the name of the link, and then we close this, the A. So this is now the link which starts in the same page and goes to the web page of the Technical University. So let's store it and let's open the web page again. Now it's underlined or underscored, so now you have this link available, and if I push to this button, it directly connects me to the Technical University. You see, it's really great. So let's extend this information. Additionally, I want to have an image. So for example, I want to have an image with my portrait. So I can start with image. This is the tag for image, and then I have source equal, where I put the source. So I can use a local image, or I can use any source, any URL which I find in the internet. So for example, I can use my official portrait image, and then I can use an alternative text. In this case, my portrait, and then I close. And if I use this without any width, it will be used in the size as it is in the original page, or I can define here a width, which is the size. For example, if I make 50, then you will see that it shrinks down to a small portrait. Okay, so let's use 150. Let's continue. You can also set a block, a P around this, so that you have a structure of different blocks. Or you can, if you want to have a little bit of gap, you can use an additional block, P. And if you have nothing to fill, then you use this N sign, NBSP, and this can be used for a white space. Okay? And then let's start with information about me, and this information would be really nice if we have it in a table. So let's create a table, and this is where you have to learn these different names of the markups. So let's create a table. Let's say the border is equal 1. This is the difficulty, especially the attributes. So if you don't use this, you have no border, so you don't see the table borders, you just see the table structure. And you have the end tag. It's always in best case if you directly write the start and the end tag directly, so that you don't forget it. But web browsers are really kind if they use HTML, because they try, even if it is not a well-defined HTML, they try to make best effort. So they try to make the best out of your structure. Okay, so therefore even if you have errors, it should work. By the way, HTML editors will do this automatically. So if you start with table, like what I have, if I start with a double quote, then I directly get both quotes. So the same will be done with an HTML editor. So then we have to create the first line. This is tr. So let's directly close it again, and then the first column in this line, or in this row, is td. And here we want to write the name, td close, and the next column is then my name. So let's have a look how it is presented. Now you see we have now a table, name and Neidhart. So what is not so nice here is that maybe I want to have this bold style, so I can do this. You can do it with additional styles, or you just use the B tag. This B tells the browser that it is now bold, and you see it is now bold. The sizes are automatically defined, and it's oriented in this case that the longest part defines the width of the whole table. So we will see this if I use call name here, Alexander, and for example the institute is FESG, and maybe the web page, so it would be possible to directly link to this institute with a link. I show it here with my web page. So I want to put a link to the web page. We already know how it works. So we have a, then we have href equal, and I bring in here my YouTube channel. It's this link, and then we close the A and we write YouTube channel, and then we have the end tag of the A, so that we have now different information sets. And if we open it again, then you will see that the longest size, though, the longest sequence of characters defines the size. If you define a width, the width is defined for all of these elements. So let's add an additional information so that you, for example, also see a list. Let's add the information like this. Sorry. Copy and paste this. And then let's say that, for example, what I like. And here we want to add now a list of information, things which I like. So therefore create a new column, and then let's say li, which is a list, and it has an end tag, and then each list element, oh sorry, ul, I forgot, ul is the list, because it's an unnumerated list. You can have numbered lists and not numbered lists, or just bullets are visible. And then you can have li, computers, I have a lot of typers today, li, and then the next one, for example, is this, programming, and this, teaching. Okay, so let's have a look into our web page. And you see now that it automatically arranges it. You can also set attributes that, for example, the alignment is defined in a special way, things like that. And that you have different sets. Usually you do this with style definitions. I just want to show you one special style definition, which is inline. This should not be done. You should use CSS, which is a style sheet. And the style sheet should also not be part of the individual web page. It should have a link here so that the style sheet is a separate format, and it uses special classes and tags which are then repeated for the information here, because then you can just change the style sheet, and then all of the web pages using this style sheet will change directly, and therefore this is the best way. Don't do it inline like I do it here. Just I want to show you, and I want to also come back to a special thing which we heard in the first lesson about the different colors and about the binary representations of colors. I do it here. again, usually you do it with a separate style sheet, and then you have something like a content management system where the whole style, the whole setup, the whole format is defined with this content management system. So I do it inside here with style equal, and then you can define different attributes, which you should also know then if you want to do this later on for the exam. It's not so relevant because you cannot learn all of these things directly just with one single web page. But you should see how it works. So red, green, blue. You remember we have a red, a green, and a blue channel, and then you can define this as red. So red is 255, the intensity is the highest, and the rest intensities are 0. Do you remember in one of the first tutorials we converted this to a binary representation with hex code, because this hex code can also be used, for example, if you have number sign FF0000. So it's the same style, and if you open then this and you reload it, then you will see that computers will be written in red. So you see, it's a really nice and simple version of creating styles for documents, and therefore this is the big advantage, and this is why it is so useful for web documents, because you can easily learn it, you can easily use it, and it's really helpful. And there's a standard style so that you don't have to do anything if you just want to use the standard style, or you can adapt the style if you use it in a way of style sheets. Okay, so that's it. So we have now a web page, and this is quite helpful. So let's go to the third question of our tutorial. The third question deals a little bit with dynamic web pages and an easy way to create such a dynamic web page. So you should write a MATLAB program which writes a web page every second, counting the seconds. So for example, presenting the date string with a second representation, and the web page should be refreshed every second, so that if the program runs, you will see in the web browser an updating web page. So let's do this. So what we need is we need a program like timewebpage.m, and in this we want to write a program which creates a web page with the date information each, for example, second. And then we have this web page, date and time.html, where then the time is running. So what you can do as a beginning, you can design your web page in an editor. This is the first thing what you should do. But then you have to write a program which prints this information, this HTML style, into a HTML file called date and time.html. So let's start this program. This is clear all, close all CLC, because we always start with this, and then it should continue as long as we will have time, so endlessly. And then we create this file, so FID, file ID equal fopen, and I store it at the location of all MATLAB files. Call it date and time.html, and I want to write text, so I open it for writing. And of course I have to close it later on, fclose, so I directly do the close bracket FID, so that I can open it and I can close it. In between here I write the HTML file, so I do it with fprintf in MATLAB, and I use FID. And then how do I start? Of course with HTML. So everything what is now part of the HTML file must be written. So I don't do it separately in an editor, I do it directly here. And I use a \n here so that I get a new line, carriage return line feed at each end of the line. And if I keep directly here the number of indents, then I have it in a nice way so that the HTML page is again readable. If you don't do this \n, if you don't use indents, then it will be a sequence of text which can be interpreted by an HTML browser, but it's not so nice readable and debuggable by humans. So then the next one is with 2 indents, head, and of course the end of head. And then we will have body, so what do we have in the body? In the body we want to print the time information. So let's do this. I use a headline h1. So and now we have to enter our information. For example, the current time is the current time is and then we have to set the time. So in this case I combine now the strings here like with a vector, and there's a nice function called date string where I can use now and where I can define the format. In my case I want to have the year with 4 numbers, then the month and the day. Then I want the hours, minutes and seconds. So it creates directly this date string, and this date string is concatenated and combined to this information. So if I start it, it will now continuously create this file, and if I open it I will see the time. So at this moment we now continuously create in the fastest speed this file, which is not necessary. So therefore let's interrupt and let's make here a short pause where you also can learn something about how often you should do this. So for example, the question asks for an update time of 1 second. So you should always have a 1 second update. And now it might be possible that you write here 1. But the problem is now that, for example, if the browser exactly asks in a wrong or in a special period, that it might happen that you get not really always an update. Therefore, there is called the Shannon theorem, where you have to use at least double of the speed of the requester. Therefore, double of the speed would be 0.5 seconds. But at least as 0.5 is divisible by 1, or 1 is divisible by 0.5, therefore you must be faster than this. So use 0.49. So therefore you have a sleep time which has also pauses, which creates the file in an interval so that it is adapted to the situation of the requester, because the requester will be 1 second and we are much farther as double of the requesting time. Okay, so this is the Shannon theorem, which is originally used in the, for example, high frequency theory, but it can also be used for computer science, and it's really, really useful here. So that we have here also the updates. we need an additional part here in the head where we set a meta information. So therefore we print this meta information where we define the update rate of the web page. And this is defined by meta. And then we say that we want to have a HTTP equif. And we say that it is a refresh of the content equal, and here we define how often. This is second, and if we add no web page here, then it refreshes the same web page as we have at the moment. And what you see here is meta has no end tag, so you can directly use it without an end tag. So what does it do? It refreshes the web page each second, the same web page. If you use here a web page, then it will jump after 1 second to this and will refresh always this web page. It's a forwarding to another web page, for example. So let's start this program again. And now it creates the web page, and if we do the update here, then you should see a running second counter. Because now what we did is we create now with this pause, we create each almost half second, faster than half second, so twice as fast as the request, or much more than twice as fast as the request. We create this web page, and we define here a tag which tells the browser that it should request the web page each second. And therefore we have now a dynamic web page in a very simple way. We have a simple program creating an HTML page which has now a counter and which shows now the update. For example, what we have here now is that it disappears, is that, for example, the browser has synchronized request where the file is empty at the moment. Therefore, you should always write the file separately and then just do a move, because moving is much faster than writing the file. And also you usually have a special iframe around which does the adaptation, so that, for example, it requests with JavaScript or something like this again the web page, so that you don't have these blindouts or these whiteouts. Okay, but for a first attempt, it's a really nice, helpful tool. So especially also for small equipments like Internet of the Thing adapters, so that you have equipment which should create over the internet a small web page with a dynamic adaptation, for example, temperature set, where you read with an Arduino or another microcontroller, read the information, and then you present it with a very small web page like this. So it's a very short program, and you have a very nice dynamical representation of the data. And this is what you should have learned in this lesson. So XML and HTML are, in a first attempt, really strange and complex structures. So XML, because the definition is quite difficult, especially if you have to define all of these things, that it is valid with XML schema or something like that. The main format is really nice, so it's very easy to create this XML. The next thing, HTML is really helpful and really easy for document style representations, so therefore it's really nice also for that. But you have to learn all of these special tags and attributes and things like that. This is what a programmer or a web page programmer has to do, and then you can easily use it for simple representations, simple dynamic adaptations. The only thing is that it's not enough here. You will have strange things like flickering effects if you do updates with this of images. Therefore, you have to learn JavaScript, Java, or other PHP or other tools. Okay, but it's a nice starting point, and therefore I think HTML and XML is quite helpful. And we'll see us again with another format which is very common in scientific communities in the next lesson. So therefore, have a nice time, and we'll see each other in the next lesson.